Hey everyone, welcome back. So today we are going to solve another Leetcode problem statement, that is jump game part 2. So here you have given an array, and what you have to do, you just have to find the minimum number of jump in order to reach from first index to last index. So here you have given 2, it means at most you can make 2 jumps. So this will be your 1 and this will be your 2. If it is 3, so it can make at most 3 jump. So this is first jump, second jump and third jump. In order to find the minimum jump, this will be your first jump, 2 to 3, and then from 3 to 4, this will be your second jump. So in 2 jump, you can do the last index. So your output will be 2. So let's quickly jump to the whiteboard and we'll see how to approach this one. So here you can see we have given array, and as we discussed, whatever element we have, at most that many times we can jump. So for that we have declared three variables. This is number of jump, and the other one which we have like how far we can jump, and this is for boundary. What will be your current boundary? So for an example, if you are at first position at index 0, it means you haven't started it. So initially all the value will be 0. In order to calculate the far, what we have to do, we just have to sum up the current element of an array and the index. Okay, then we will get the value of far. Initially, you are standing at this position. At the same time, as you haven't made any jump, so your boundary will be this one only. So the current end will be 0 only. The first thing is we have to calculate the far. In order to calculate the far, what we have to do, we just have to sum up the current element, that is 2, and the index 0, it will be 2. So first we have to see whether this 2 is greater than the existing far value. In this case, yes, then we just have to update this far. And if you are standing at a index and same index is your current boundary, then what you have to do, you just have to increment the value of jump, and at the same time you just have to update the value of current end. It means this value is same, so what we have to do, first we have to increment the value of jump, and in the very next step we just have to set the boundary, like till where we can jump, so that will be your farthest. So this one also we will update to 2. Then your boundary, then your current end will come at index 2. In the very next step, what you have to do, you just have to increment the value of I. Once you will increment the value of I, what you have to do, you just have to calculate the far. So 3 plus 1, it will be 4. So you have to see whether this 4 is greater than the current far value. In this case, yes. So we just have to update this one. Okay. Now we have to do what we have to do. We have to check whether this I and C is in same index. In this case, it is not. So we just have to increment the value of I. Now what we have to do, first thing we have to calculate the value of far. 1 plus 2 is 3. Then we have to see whether this 3 is greater than far. If it is greater, then only we have to update the far value, or else we don't have to. So it is not greater, so we will not update it. But we will see that I and C is same. It means you reach to your dead end, right? Dead end of this boundary. So next thing is you have to make another jump. In order to make another jump, you have to define the next boundary. So next boundary will be your far. So whatever far value you will have, that value will be your next boundary, and you have to increment the value of jump. Now your C will come at index 4. After that, you just have to increment the value of I. Now 3 plus 1, that is 4. So you have to see whether this 4 is greater than the current value of far. In this case, it is same, so we don't have to do anything. And the value of I and C is not same. So what you have to do, the iteration which you have to move, right, it will be, I will move from 0 to length minus 1. That's it. And what you have to do, you just have to return this jump. In this case, the value is, the output is 2. So let me quickly jump to the Leetcode compiler and we'll see how to code this one. As we discussed, the first thing which we need is jump variable. It will tell you how many jumps you have made in order to reach from index 0 to last. Another thing is we need current end. What will be your boundary? and at last you need how far you can go. Everything will initialize by 0. In the very next step, you have to start the loop, and loop will go from 0 to length minus 1. Okay, and then we have to increment each time. After that, what you have to do, you have to calculate the farthest value. So there is a typo, let me remove this one. Yes. How we will calculate? We will just use a function of math, that is max. Either this farthest or the current element and plus index, whichever is greater, that will be your farthest value. If you are standing at the same position, if you are standing at the same position of your dead end boundary, then what you have to do? You just have to increment the value of jump by 1, and you have to update the dead end boundary, current boundary, that will be your farthest. And at the end, you just have to return the number of jump. So let me quickly execute this code and we'll see whether we are getting expected output or not. So in this case, both the test cases passed successfully. Now I'm going to submit this solution. Perfect. So this is the approach we have to follow in order to solve this kind of problem statement. If you like the video, do subscribe the channel. Thank you for watching. Enjoy your day.